Hello everyone, today I'll share how to use the NE555 to make a touch delay lamp or a touch delay switch. For the actual circuit I built one using this small board, you can take a look. As long as I touch this metal wire, the LED will turn on. After a delay, the LED will turn off again. Let me demonstrate it. I'm touching this metal wire now and you can see the light turns on. After some time, the light turns off again. When I touch it again, it lights up again. Now, let's take a look at the circuit diagram of the NE555 touch lamp. Pin 4 is the reset pin, and it is connected to an RC network. Pins 6 and 7 are connected together and also connected to an RC network. Pin 2 is connected through a resistor divider network. These two resistors are usually equal, so after power up, the voltage on pin 2 is a half VC. These divider resistors usually have large resistance values. With large resistance, the divided voltage has poor noise immunity. When touched by hand, noise signals couple into pin 2. When the voltage on pin 2 drops below a third VC, the output becomes high. At other times, the output remains low. We can look at the NE555 input-output table. During power up, the reset pin is connected to an RC network. So after VC rises, reset is still at a low level at this time. The output is 0 volt. The internal transistor is conducting. Pins 6 and 7 are also at 0 volt. After power up, since the voltage on pin 2 is a half VC and the voltage on pins 6 and 7 is 0, the internal transistor remains on. Therefore, pin 3 outputs 0 volt. When I touch the metal plate connected to pin 2, noise from the hand causes the voltage on pin 2 to drop below a third VC. At this moment, the internal transistor turns off. Pins 6 and 7 start charging. The charging voltage rises from 0 volt to 2/3 VC. The time equals RC lane 3. This R is the resistor connected to pins 6 and 7. C is the capacitor. During this period, pin 3 outputs a high level. The LED is on. After the touch, the voltage on pin 2 returns to a half VC. When pin 6 charges up to 2/3 VC, the internal transistor turns on again. Then it starts discharging. Pin 3 output returns to 0 volt. The LED turns off. That is the principle of using the NE555 as a touch lamp or touch switch. This circuit can also drive a relay so it can control high power loads. Here are the circuit parameters of the demonstrated project. The divider resistors on pin 2 are 1 ohm. The capacitor on pins 6 and 7 is 100 F. To adjust the delay time, we replace the resistor with a 100K potentiometer. Next, I'll use 3 oscilloscope probes to measure the waveforms. Probe 1 is connected to the output pin. Probe 2 is connected to pin 2. Probe 3 is connected to pins 6 and 7. Now let's measure the waveforms. The oscilloscope now shows the voltage waveforms of pins 2, 3, 6, and 7. The yellow trace is pin 3 output, currently at 0 volt. The blue trace is pin 2, about 2.1 volts. The theoretical value is about 2.5 volts. Due to resistor tolerance, the divided voltage varies slightly. The green trace is pin 6 and 7, currently at 0 volt. Next, I set the oscilloscope trigger and touch the metal plate. This shows the waveform when I just touched the metal plate. The blue trace is noise introduced by the hand. The yellow trace is the output switching from low to high. This crossing point corresponds to a third VC measured here. It is about 1.48 volt. This is close to the expected 1.6 minus 1.7 V of a third VC. Now let's look at the voltage change on pins 6 and 7. This point corresponds to the touch moment. Pins 6 and 7 begin charging slowly. After reaching this point, they start discharging. This voltage corresponds to 2/3 VC. Measured value is about 3 volts. The theoretical 2/3 VC is about 3.3 volts. There is also some deviation. That's basically how to make a touch delay lamp or touch delay switch using the NE555. That's all for today. Thank you everyone.